Thank you so much for joining this lesson. Today we shall be discussing the Kapsabet High School Post-Mock 2025 Mathematics Paper 2. Thank you for turning up, guys. Remember to subscribe. Remember to share so that you may invite a friend. We shall be discussing the section 1 of this paper, and later the section 2 shall be uploaded in this channel, Shifting Grades Online School, the home of academics. So kindly make a plan of being a frequent visitor of our channel. I'm also inviting all the continuing students to our serious programs here for the December and November holidays. Look at the wonderful timetable. This is for the senior school students, or rather the secondary school students. This is what you'll be covering: mathematics, chemistry, biology, physics, Kiswahili, and English. So please make an appointment of visiting our platforms. Remember, our number is already attached. The number that you should use to reach out, 0704 15 3366. Please reach out. These are impactful, interactive, and transformative lessons. The junior school students are also invited. Remember, when you talk about junior school, now we mean the 2025 grade 6, grade 7s and 8s, who are going to be grade 7s, 8s, and 9s, respectively, in 2026. So please book an appointment with us and get an experience of the best teachers, the best tutors, the best facilitators will be overseeing this particular exercise. You are all invited. Ensure to invite a friend. Now back to the Kapsabet post-mock, a very serious paper that I want us to discuss it word by word, number by number, bit by bit, in between the lines, until everybody understands what the examiners actually required for this particular paper. Now, without using logarithm tables or calculator, evaluate the logarithm to base 10 of 96 plus 3/4 the logarithm to base 10 of 625 minus the log to base 10 of 12. Here, we shall be led by what we call the laws of logarithms, and also, to some extent, the laws of indices. So let's look at the first term, whereby I'm just going to write it as the log to base 10, then plus, then plus. Look at this third law, which says whenever we have n, the logarithm of a, this one is solved by taking the log of a power n. So with that law, now we can talk about the logarithm to base 10 of 625. Then this is raised to power 3/4 minus the log to base 10 of 12. That's one step. We have applied one law. Can we go to another law? And this time around, a law of indices that says when a number is raised to a fractional power. Look at this. Let's say we are having a power m out of n. That's our fractional index. We solve this one by taking the nth root of a. Then now everything is usually raised to power m. So that's how we handle a fractional index. So we will talk about now 625 raised to 3/4. We take the fourth root of 625. Then now the resulting answer after that, we cube it. This will be 5 because the fourth root of 625 is 5. Then now 5 will be raised to power 3, giving us 125. That is now some bit of indices. So the logarithm to base 10 of 96 plus the log to base 10 of 125 minus the log to base 10 of 12. Then now I will talk about the first law of logarithms together with the second law of logarithms. Whenever you have the log to a certain base, say base a of b, plus the log to the same base, but now the log of c, this one is usually solved by the log to base a, then b is multiplied by c, like that. But now when it is a minus, if you have the log a minus the log to the same base a of c, this one is now the log to base a, then c and b are divided in that order, b out of c, meaning that this can now be applied jointly. We apply the two laws because you have a plus and also a minus in the same expression. Then we will talk about the log to base 10 of 96. Because of the plus, we multiply by 125. And now there is a minus, we divide by. This shall be the log to base 10 of 96 multiplied by 125 out of 12, giving us 1,000. So the log to base 10 of 1,000. And now we have to finalize now. What is the value of log 1,000 to base 10? This now can be written as the log to base 10 of 10 power 3. Log to base 10 of power 3. And we get back to the law that we applied first. This law, now we apply the same, but now in the reverse way. Applying the same law in the reverse way, this will give us now 3 multiplied by the log of 10 to base 10. Now, we apply the final law, which will lead us to the final answer. The law that says whenever you have the log to a number under the same base, the value is usually 1. The log of a number to the same base is usually equal to 1, meaning that now we multiply 3 by 1, giving us a final answer of 3. Of course, I'm listing all the laws because I'm explaining to you. I'm listing all the laws just because I'm explaining them to you. When you're doing in the exam, you're just supposed to imply the laws. You're not necessarily supposed to write for the examiner the laws. Just apply them directly. Yeah, thank you. Thank you for joining. Remember, we're wishing all the candidates of 2025 success. First timers to shifting grades, please remember to subscribe. Remember to share our link so that you may invite somebody to our powerful lessons. Number 2, now find the value of P if the expression px power 2 minus 60x plus 25 is a perfect square, given that P is a constant. P is a constant, so it can be an integer, it can be a fraction, as long as it's a constant. So let's just remember this. Whenever you are given a then you have x at this point, ax power 2, then plus bx, then plus a constant as a perfect square expression, then this implies that if this is a perfect square expression, ladies and gentlemen, then it should directly imply that whenever we take the value of b out of 2 and we square, we're supposed to get a times c. That is how the terms in a perfect square are related. That is how the terms in a perfect square are related. The value of b out of 2 squared should be equal to a multiplied by c. Therefore, now with reference to the specific perfect square provided up there, we talk about negative 16 out of 2. This squared should be p, which is our a, multiplied by c, which is 25. So now we can talk about now, 30 squared, or rather negative 30 squared. And remember to include the 30 in brackets. Negative 30 should be in brackets. Let that one be noted, please. Don't just write negative 30 in your calculator. You type negative 30 squared. The 30 will not be squared. The negative will remain unsquared. And that's a mistake. So start with brackets, negative 30 squared. That becomes 900 equals to p by 25, or rather equals to 25p. Let me be logical. 25p, meaning that we can remain with p now by taking 900 out of 25. This takes us to exactly 36, ladies and gentlemen. That takes us to 36. So the value of p that can be fixed there to make the whole expression a perfect square is 36. That's 36. All right. We're looking at number 3, ladies and gentlemen. Now, the price of a new car is 800,000 Kenya shillings. I don't know what type of a car is that. When very new, it's costing 800,000 Kenya shillings, okay? Now, if it depreciates at a constant rate to 550,000 Kenya shillings within 4 years, find the annual rate of depreciation to 2 decimal places. We are supposed to know that according to the formula for depreciation, new value is given by P, original value, 1 minus the rate of interest, the rate of depreciation, which is a percentage raised to the number of seasons over which this particular item has depreciated. So we have new value already as 550,000 equals to 800,000 into 1 minus a known rate expressed as a percent. Then this is raised to power 4 because of the 4 years, right? At this point, let's talk about dividing through by 800,000. So that 550,000, when divided by 800,000 now, it becomes 0.6875. This is equal to 1 minus r over 100, and this part has been raised to power 4. Are we together at that point? Yes. So now, because this is to power 4, we can take the fourth root both sides. 4 shift power 0.6875. And this will give us, this one now shall give us, when we type it like that, this is giving us 0.91058. This is equal to 1 minus r over 100. Okay. This is a very interesting question, ladies and gentlemen. But just to ask, are you a subscribed member of Shifting Grades? Are you a subscribed member of Shifting Grades? If not yet, kindly ensure to subscribe. Okay. Now we can finalize in the process of finding the value of R, our rate of depreciation. We can take the rate to the left-hand side way to be positive, so that we have 1 minus 0.91058, giving us 0.08948. 0.0894. Can I have it as 42? Yeah, to four significant figures. 42. Then after this point, ladies and gentlemen, we can now remain with the value of R by multiplying through by 100. And this takes us to 8.94. Remember, we've been instructed to work with 2dp. So 8.94 now becomes our percentage rate of depreciation. Yeah, that's our percentage rate of depreciation. Otherwise, thank you. Thank you guys for just being around. It's a great motivation to see you following shifting grades. Remember to invite a friend. If you have a brother, a sister, a sibling, a friend in senior school, kindly invite them to our serious program here, hoping to see them for a very interactive, impactful, and transformative platform via Google Meet. So kindly reach out through our number 0704 15 33 66. So that's the number you're supposed to reach out through. Yeah, so that you may keep in touch with Shifting Grades Online School. Looking at number 4 now, right? Mwangi truncated 7 out of 9 to 3 decimal places. Now calculate the percentage error resulting from the truncation. What you're supposed to know here, ladies and gentlemen, is that whenever you truncate, there is a truncation error. And this is given by the actual minus the truncated value. So let's first express the 7 out of 9. This is 0.777. The 7 is recurring. Now, when you are told that Mwangi truncated to 3 decimal places, then it means he just truncated like that. 0.77, and even without considering what is next, because this is like this now. We're having 7, 7, 7, So when you talk about truncating, it means after the third decimal point, he doesn't even consider what is to the right, so that he may know whether it becomes 0.778 or it has to remain 0.777. He just truncates. Therefore, we have now the truncated value and we have the actual value. So we can get the error first. For us to get the error, we need to take actual value minus truncated value. Actual value minus truncated value. Then after that now, we can talk about the percentage error. Percentage error, which is hereby given by error over actual times 100. What percentage of the actual is this error, but now expressed as a percentage? So 7 over 9 minus 0.777, yeah, truncated to 3dp. Then this now has to be divided by the actual. Then after that, we now multiply by 100, so that we get it now as percentage error. Yeah, so that you get it as a percentage error, we have to multiply. It's my hope that you are accessing our screen in a very good way. Confirm by just commenting. Are you able to see our screen properly? Are you able to know what we are doing, ladies and gentlemen? This one multiplied by 100, as I said, percent. So now this can go now to the calculator, ladies and gentlemen. Calculates the percentage error. So we've not been given restrictions on the accuracy to follow. So allow me just say 7 over 9 minus 0.777. Then after getting this now, I have to divide again by 7/9. Then now I multiply by 100. You know, I'm getting exactly 0.1. So this now the percentage error. This is the percentage error according to the above question. We proceed to the fifth question of this particular paper. Now we are told that the position vector of A and B are just as given there. 4i plus 4j minus 6k. And for B is a 10i plus 4j plus 12k. Then there is a point D on AB such that from A to D, or the ratio of A to D, D to B is 2:1. Find the coordinates of D. According to how the ratio has been stated at this point, just according to this, it means moving from point A, this is simply internal division of a line, proportional division of lines, internal case. So with A here, we usually move to a point D, then we proceed to B. And now, if we interpret this ratio very well, A to D, D to B, it means we have two proportions here and one proportion here. And you know, there are some already provided position vectors, meaning that we can find coordinates. According to the position of A, then it means the coordinates of A is 4, 4, and -6. Then when you go to B, you extract the coordinates from the position vector there, 10, 4, 12. 10, 4, 12. Then the other one was 4, 4, -6, right? According to the ratio theorem, ladies and gentlemen, you know, we've covered a lot of ratio theorem even when it is external division of lines. So now that it is internal division of a line, I want you to get it very clearly. I want you to get it well. Please get it well. That you're supposed to do this. You pick a proportion like 2 out of total proportions in this expression, which are 3, because you have 2 and 3. Then if you picked 2 now, we multiply this by the opposite vector, which is 10, 4, and 12. Then you add the other proportion, which is a 1, out of total proportions 3. And because you've picked 1, we multiply it with the opposite vector, 4, 4, -6. After adding this, you get the position of D. So let's work out the position of D. Now, from the x components, I'll be having 2/3 by 10, giving us 20/10. 20/3, sorry. 20/3, I should add 1/3 times 4, which is 4/3. In such a case, I'm getting only 8. So the position of D can now be found 8i, according to the x components. Then we go again to 2/3 times 4. That is 8 out of 4. Then I add, then I add 1/3 multiplied by 4, which is still 4/3. Now this taking me to 3 1/3. 3 1/3 as the position. Though we have to confirm very keenly, we talked of 8/3, 8/3. Then we're also talking about 4/3. And its addition, 4/3, and we are adding. No, we're getting exactly 4, a positive vector J. Then finally, 2/3 by 12. Does it simplify? Yes. 2/3 by 12, it becomes 8. 2/3 by 12, it just becomes 8. So we are having 8, then negative 2. Negative 2 because a third times negative 6 shall simplify to negative 2. So that becomes positive 6. Okay. And now we are supposed to write D as a coordinate. So D equals to, this is the position. So D equals to 8, 4, 6. Now, when told to find coordinates, it's good for you to ensure, take it as a personal responsibility of ensuring one thing here, ensuring that you don't leave it as a position vector, and you also don't leave it as a column vector. You finalize and give us a coordinate. A coordinate should just be a coordinate. So let's not complicate simple matters here and there. Let coordinates be coordinates. Okay, look at number 6, ladies and gentlemen. A quantity y varies partly as x squared and partly as x. That's now partial variations, okay? When y equals to 6 and x equals to 1, then you're also told when y equals to 30, x equals to 3. Find the value of y when x equals to negative 3. So now we proceed to first interpret this particular partial variation statement where y is varying partly as x squared and partly, so we add partly as x now. Partly as x squared and partly as x. So we can do away with the symbol of proportionality by introducing an equal sign and two constants. Whenever it's partial variation, we usually introduce two constants, right? Therefore, now we can have a constant like k that multiplies x squared and another constant, maybe c, that multiplies x. So we have two constants here. In this case, k and c are constants. Now, according to the information provided here, we shall now be able to come up with two simultaneous equations. You know, there are those who think simultaneous equations is just a paper 1 concept that should not be considered when revising for paper 2. But remember, there are a lot of questions which you will solve and you will land yourself in a simultaneous equation and you have to solve that pair by whichever method. We have one example here. We also have the cases of, apart from variations, you can find simultaneous equation even when you are handling sequences and series, plus very many other topics that will just have simultaneous equations emerging together with quadratic equations. So let's just be very keen with the equations, simultaneous, quadratic. Let's just know how to solve them. Not necessarily for us to solve when you are told to solve the equation below, but so that you may apply in diverse topics like the one we have. So let's come up with a few equations here, like y equals to 6. So 6, when x is 1. So even when you square 1, it becomes 1. So k times 1. You get me? Then plus c multiplied by the value of x, which is just 1. So this is our first equation. I call it equation 1. What about the second scenario? Y equals to 30 when the value of x is 3. So in the first case, you square 3, you get 9k plus 3 the way it is times constant c. So we have two equations that are supposed to be solved simultaneously. The quickest method here will be substitution, just because the constants in the first expression have coefficients of 1. When the coefficient of unknown is 1, it becomes very easy to express that particular constant. Therefore, c equals to 6 minus k from equation 1. From 1, the value of c can be expressed as 6 minus k, because you take k to the left where it shall be subtracted. Now equation 2 can be rewritten 9k plus 3 into 6 minus k. Instead of the value of c, We write 3, 6 minus k. 30 equals to 9k plus 18 minus 3k. Grouping of term, ladies and gentlemen, shall give us positive 6k. Is that okay? Yeah, 9 minus 3. That gives us positive 6k. Then at the same time now, we should be able to take 30 and we subtract 18 from it. And ladies and gentlemen, we are getting 12. When that is so, it means the value of k can now be found as you divide through by 6, and this becomes positive 2. So the value of k is 2 according to the variations above. Now that we got the value of k, we can quickly find the value of c. Remember, c has already been expressed. Remember, c has already been expressed. So c equals to 6 minus a value here, which is already known. According to this equation at this point, we just now substitute. This becomes positive 4. So we have c and k, meaning that now the general equation at this point can now be made specific. Specific equation that connects y and x. So the value of y equals to k, which is 2, x squared, plus a constant c, which is 4, the value of x. So we have now the specific equation. But now that is not the end. After finding the equation that connects y and x, we are now to proceed and find the value of y when x is negative 3 plus 4 into negative 3. So we just substitute a negative 3 wherever we find x. 2 into negative 3 squared, then plus 4 into negative 3. This is taking us to exactly value of y as 6. The value of y equals to 6. That's a very interesting question. Very good. Please make sure you review. Through Shifting Grades Online School, you'll find a variety of these. You'll also find the joint variations together with percentage change in quantities, plus very many other. Okay? Yeah. We now in number 7, right? Yeah, very good question here. The coordinates of the end points of a diameter are point A, 4, point B, 6. Find the equation of a circle in the form ax power 2 plus by squared plus cx plus dy plus e. This is equal to 0. This one is equal to 0. So generally, we are supposed to interpret this particular problem. We're supposed to interpret it right from the drawing of the circle. So we can do a circle. It's just a sketchy circle. Then after the circle is done like that, we should be able now to talk about a certain diameter. A certain diameter. Now with this particular diameter, which behaves like this is a diameter. The end of this particular diameter, let's say this is A, and this is B. Now we have the coordinates of A and B. This is a 2, 6, I see. Think logically. Though we are not drawing to scale, A should be here as coordinate 2, 4. Then now B is up there as coordinate 2, 6. How can we find the center of this circle? How can we find the center of this circle? Now that A and B are the points at the end of the diameter of a circle, it follows without saying that the midpoint of this diameter is the center of the circle. And from vector 1, we know how to find the coordinates of a midpoint. So the center of the circle that I'm calling C will be given by x1 plus x2 divided by 2. So 2 plus 2, then we take average, comma, the first y plus the other y, we also take the average. That will give us the midpoint of diameter AB, and hence we will find the coordinates of the center, which you can see now it's center 2, 5. After getting the center, ladies and gentlemen, the other thing that we supposed to establish is the radius of the circle. Remember, you can't just find the equation of a circle until you have the center and also the radius of the circle. Therefore, at this point, ladies and gentlemen, at this particular point, now you will have to allow me and talk about the radius now. The radius can be found in very many ways. One, when you look at the changes in x coordinates, x is not varying. X is 2 at coordinate A, and at C, we find x is also 2. Then at B, it's also 2, meaning that we are just moving upwards from A to the center. How many units are there? It's only 1 unit. Only 1 unit. So the radius is 1 unit. And that's my own approach, because you can see you're just raising up from y being 4 to y becoming 5. And you can even consider from C to B, y is 5 changing to 6. So that's just an advancement by 1 unit. Otherwise, you can also check from A to B. There are 2 units. From x being 4, from the value of y, sorry, not x, from the value of y being 4 to value of y becoming 6. That means the diameter is 2 units. And if diameter is 2 units, then we can talk about a radius, which is 1 unit. Alternatively, you can think big and talk about vector 1. You can talk about vector 1, the modulus of a vector. How do we get the magnitude of a vector? Where simply you can talk about vector AC. You know, vector AC. First, you have to find vector AC, whereby you take C to 5 minus A to 4. You know, this is now 0, and these are 1 unit, right? Yeah. Then now to get magnitude of AC, you're supposed now to take 0 squared plus 1 squared, then the square root. And this still confirms. This still affirms that the radius is 1. That is from vector 1. You can simply express a vector, then you find its length, and that will give you the radius. You can also talk about the whole length AB, so that the length of AB now will be used as the diameter. You divide it by 2. Generally, we say for us to get equation of a circle, we need x minus a. In this case, a is the x coordinate of the center, plus y minus b. B is the y coordinate of the center squared. This is all equal to radius squared. Therefore, we need x minus the x coordinate of the center is 2, we square, plus y minus 5, because the 5 is the y coordinates of the center, is equals to the radius of 1, also squared. At this point now, let's talk about x squared minus 4x plus 4, then plus y squared minus 10y plus 25, and this is equal to 1. So now after that expansion, you can go directly now to the format of the equation that the examiner demands. Remember, at this point, you are even correct. When you have 1 squared as 1, already that's our format of equation of a circle. But now the examiner has gone into the details. That's why we add to expand. Then now we're supposed to group terms together. The term with x squared, that should begin, x squared. The term with y squared, that should follow. So y y squared, okay. We have y squared. Then now the term with x, so negative 4 x. Then the term with y, minus 10y. Then finally, we combine the constants. We already have 4 plus 25. Then the 1 should be subtracted. So we get plus 28 here. This is equal to 0. So this is the equation now in the format that the examiner exactly needs it. It's my very good hope that you guys are getting what we are talking about. A very good question. Remember to subscribe, remember to share, remember to invite a friend to the powerful broadcast. Let's look at number 8, ladies and gentlemen. Let's look at number 8. In number 8, we are told this, that a bag, bag M, contains eight balls, of which 3 are red, 5 are white. Another bag contains 7 balls, of which 3 are red and 3 are white. Now, a bag is chosen at random and 2 balls picked at random without replacement. Underline the word without replacement. Using a tree diagram. That one is key. You see it has even been bolded. Using a tree diagram, find the probability that the 2 balls chosen are red in color. The probability that the 2 balls chosen are red in color. So we are first talking about the picking of a bag first. So bags are two, remember? So let me have now bag M and bag N. So we have bag M and another bag that we are calling N. If they are only 2, I'm assuming that they are very similar bags. So we have half and half probabilities of picking any of the bags. Then after that now, just check the next. So now you pick a bag first, and the probabilities of picking any bag has already been displayed. So when you pick a ball from M, it can either be red or white. So from M, we can pick red or white. The probability to pick a red ball is 3 out of the possible 8. And picking a white one is 5 out of 8. That is after the first picking. If you had picked N and then you pick a ball from it, you draw a ball, it can be red or white. Now, what is the probability of picking red for bag N? 7 balls, of which 4 are red. So 4 out of the total 7, then 3 out of the total 7, like that. Now, let's do the second picking now. Let's do the second picking. Remember, there is no replacement. So the bag that you've picked, then you chose a ball from it. This ball has not been replaced. If the ball has not been replaced, ladies and gentlemen, then it means we have a new total. And that's why we can talk about, after picking red, you can pick a red again or still white. So what is the probability of picking red when you had already picked a red? It means the reds have reduced and they are now 2. And because you didn't replace, it's now out of 7. Then we go to the white remaining 5 over 7. And you go to the next. You can pick red or white. Now, if you had picked white in the first picking another white, the white ones have gone down to 4 out of a new total because you didn't replace. And the red ones now shall be 3 out of 7. Can we talk about another picking here? When you had picked a red from N, you can proceed with picking another red or white. Picking a red, when you had picked a red from N, now the red ones have become 3, and the new total is 6, meaning that these ones are also 3 over 6. And finally, when you had picked white from N, if you had picked white from N, you can pick red or still another white. Picking white again, the probability has to go down to 2 and now out of 6, meaning that the R should mean 4 over 6. So we have the outcomes properly displayed at the end of every branch and the probabilities alongside the branches. At this point, ladies and gentlemen, we can now talk about bag M. You know, we are finding the probability. I wanted to list all the outcomes, but allow me kindly concentrate on this question. M, red, red, or from bag M, red, white. From bag M, white followed by a red, bag M, white followed by a white. Then in bag N now, a red followed by a red, bag N, a red followed by a white, in bag N, a white, then a red, and finally in the same bag N, a white followed by a white. Let me copy it very well. Just look at that analysis of the tree diagram. Look at that analysis of the tree diagram. So you have N, W, W. Those are now the possible outcomes. Just make it that clear for purposes of section 2. Sometimes you'll be given a question like this, and it will be carrying some healthy marks, very good marks. So it's encouraged for you to outline all the probabilities now at the end of every branch like that. We need now probability that the two chosen are red. So it can be probability from bag M, we picked red, followed by red, or probability that from bag N, we picked red, followed by red. So that's simply what you need. Bag M as a probability of half multiplied by red, 3 over 8, multiplied by red again, 2 over 7, comma. When we talk about OR, that is the addition law in probability. So we're supposed to add, ladies and gentlemen. Picking N is half, multiplied by red in N, 4 over 7, and red again is 3 out of 6. So this now what we exactly needed. This is what we needed. From there now, we expect you at the answer from such a step. Now we expect you at the answer, you compute, you get 3 over 56. Then you add 1 over 7. This will take us to 11 out of 56. So that's now the final answer. And that is what the examiners wanted in such a wonderful question. Are we at number 9 now? Okay, we are rushing. We're moving very fast. Guys, remember to subscribe. Remember to share so that you may invite some friends to the powerful broadcast. Find the equation of the tangent to the curve below at the indicated point. So equation of a curve. One thing that you're supposed to know is that at a given point, when the value of x is provided, there is usually a corresponding y value. So when x is 2, what is the value of y? 2 should be cubed plus 3, 2 being squared, 2 squared, then minus 3. Can we work out that? Yes. 2 power 3, that's the beginning point, then plus 3 into 2 raised to power 2, then minus 3 now. This gives us exactly 17. So we have a coordinate 2, 17. We are talking about now a tangent that passes through point 2, 17. So let's embrace the computing. Let's embrace the computing of coordinates. Let's express the computing of coordinates that way. Something else that we're supposed to understand now is that when we talk about equation of a tangent, we can now operate from the gradient point, whereby at a given point, gradient of a curve is usually equal to gradient of a tangent that passes at that particular point on the particular curve. So we can get gradient function, ladies and gentlemen. So the gradient function now shall be, we integrate the function with respect to x. So power 3 x, and the new power becomes 2. Then 2 drops to multiply 3, making it a 6. And x now becomes power 1. Yeah, that is now the gradient function. The negative 3 is a constant, so it disappears upon differentiation. So now if this is the gradient function, can we find the gradient itself? Gradient is usually given by 3 when x is 2, like that. You see, we'll be talking about 3 into 2 power 2 plus 6 into 2, and the gradient is exactly 24. So the gradient of the curve at x equals to 2 is 24. This now is implied. It is automatically the gradient of the tangent at the same point. If we were talking about the normal, then we would have said normal is perpendicular to the tangent. But in this case, this gradient that we have is also the gradient of the curve at x equals to 2, and it's also the gradient of the tangent. So can we express gradient now? 24 equals to, change in y minus 17 according to the coordinate. Change in x minus 2. And we now proceed to a cross multiplication. This automatically over 1. So y minus 17 equals to 24x minus 48. How can we remain with exactly y? 24x, 24x. Then now we are having negative 48 plus 17, because now 17 has to be added. We get a negative 31. Negative 31. So now this is the equation of the tangent to the curve at that particular point. A very interesting question. Remember, guys, to reach out through 0704 153366. That's also our M-Pesa line. If you feel you are really getting helped, you can also oil our hands. You can grease our hands using that particular number. Wow. Secondary school students. Guys, you are the luckiest. You are among the luckiest. Look at your timetable here, guys, whereby you're supposed to just enroll. Reach out through the number that I've already displayed. It's here, 0704153366. Reach out through that number so that you may discuss this particular program that will be happening via Google Meet. Even your brothers and sisters who are in junior school, they are highly invited. They have their own parallel program. When you register, The junior school schedule is parallel to the senior one. So every people will be learning at their own time, education of their own level and type. So please feel free to reach out for our successful, for our impactful, for our interactive and transformative lessons. You are all invited. Number 10, this is on trigonometry, ladies and gentlemen. Solve the equation 8 sine squared of x equals to 7 minus 2 the cosine of x. The values of x, of course, now ranging between 0 and 360. Remember, the first thing that you're supposed to do, just examine the nature of the trigonometric equation that you have been given. For instance, in our case, ladies and gentlemen, I can see that there is sine squared. And what should click in my mind? The trigonometric identity that says whenever we have the sine squared of an angle theta plus the cosine squared of theta, we usually get 1. So from this now we can reshuffle and have the cosine, no, the sine expressed equals to 1 minus the cosine squared of theta. So sine squared theta equals to cosine squared theta. So instead of sine now of x, we can replace it and have 8. So instead of sine squared, we have 1 minus the cosine squared of x equals to 7 minus 2 the cosine of x. At a step like this, ladies and gentlemen, can we open 8 minus 8 the cosine squared of x equals to 7 minus 2 the cosine of x. At this point, we can rearrange the equation to take some shape. For instance, we can have the 8 cosine squared of x coming to the left. Then we have already a minus 2 the cosine of x. Then we are adding 7, and now we are supposed to subtract 8. You see, it now has to become a negative 1 because of 7 minus 8. Now this leaves us with a 0 there. Our equation is what we call quadratic now, because if we let the cosine of x to be a certain unknown, say even t, to be unknown like t, then we can say 8t squared minus 2t minus 1 is equal to 0. Then we solve this one now quadratically, a product of a times c, which is negative 8, and a sum of the value at b, which is a negative 2. So now these two factors multiplied to give us negative 8 and added to give us negative 2 shall be negative 4 and a positive 2. Yeah. Negative 4, positive 2. You multiply. You multiply. You are taken to negative 8. You add negative 2. All right. So at that point now, we can write 8 t squared minus 4t and positive 2t, then minus 1 equals to 0. You see, this is now, instead of negative 2, according to the factorization method, I'm now substituting it with a negative 4 and a positive 2. You see that? So now we can factorize from the first two. What is common? 40. So 40 is factored out, and this leaves us with 2 times t, then minus 1. In the other two here, it's only 1 that is common. It should be positive 1. 2t minus 1 that way. Or this equal to 0. Allow me manage the space from the topmost space here. We have already applied the identity. So let me clear up the space at that point. Now, at this point, ladies and gentlemen, you shall allow me to say this. Allow me to say this, that from inside the brackets, we have 2t minus 1. Then from outside the brackets, there is a 4t and a positive 1. 14 plus 1. This now equal to 0. We can proceed now to solve. We can proceed to solve. You know, from this look of things here, the value of t shall be equal to half, or the value of t shall be equal to -1 out of 4, which is -1/4. Yeah, because 1 to the left shall be, 1 to the right shall be positive, 1 to the right shall be negative, then we divide by 4. So this is it. This is it. So now we get back to the unit circle. We get back to what we had let to be t. What we had let to be t. Well, let me do the unit circle first. That's the unit circle with a vertical axis and a horizontal axis. With a vertical axis and a horizontal axis like that. Vertical and horizontal axis. At this point, we're not supposed to know that with a unit circle, all trigonometric ratios are positive in the first quadrant. Only sines are positive in the second. Only tangents are positive in the third, and only cosines are positive in the fourth quadrant. Those who use some acronyms say that for them to have a clear remembrance. All students take coffee. Yeah, all students take coffee. Or in the clockwise direction, you can talk about acts. You can talk about acts of apostles. Okay, now let's now narrow down our question now. You see, with the first value of t, it means that with the first value of t, it means that the cosine of x equals to half. This is a positive value. First, we need to get an angle. Let me call it theta, which is given by cos inverse of half. And you see, shift the cosine of half is giving us 60. So the acute angle is 60. But now the values of x shall be this particular angle in the quadrants where cosines are positive, just like the half that we had. So in the quadrants where cosines are positive shall be the first 60, then the last quadrant, the fourth quadrant. How do we get angles in the fourth quadrant? We need 360 minus theta, which is giving us exactly 300. So those are the first two angles. We're supposed to know that in the first quadrant, we talk about the angle as theta, the acute angle. But if an angle lies in the second quadrant, it should be equal to 180 minus theta. If an angle lies in the third quadrant, it should be 180. It should be 180 plus beta. And if it's in the last, 360 minus beta. So it depends on where you are addressing your data. It depends on where you are addressing the value of beta. Let's check the next value of t, which is here. So the cosine of x is also negative a quarter. The cosine of x equals to negative a quarter, meaning that we're supposed to deal first with an acute angle. Allow me, because you've dealt with theta, allow me call it angle alpha, which is equal to the cos inverse of a quarter. Look at that, a quarter, not a negative a quarter. Shift cosine of a quarter. This gives us 75.52. 75.52. But now, are we interested in this alpha? No. What we need now are values of x. And the values of x shall be the angle of 75.52, but in the quadrants where cosines are negative. So where are cosines negative? In the second and the third quadrant. So 180 minus beta, giving us 104.48, and in the third, which is 180, we add, in the third we add 75.52. You know, this takes us now to 255.52 degrees. Making you now, if you want to gather now the values of x, which you should, the values of x now can be assembled. So x equals to, we got values as 60. We are getting other values like 104.48. We are also getting 255.52. And we're also talking about 300. I've just organized the angles in ascending order. It's not a rule. You must not. It's not a must, in other words. You don't have to arrange, but I saw it good to arrange them in that particular order. So that's it. That's it. A trigonometric question, which is really involving and requires you to really have the right content when it comes to topics like this. You should be well informed. You should be well equipped with trigonometric knowledge. Yeah. Proceeding to 11 now. Guys, remember to subscribe. Just remember to share so that you may invite people. I hope you are following very keenly. I hope in case you get questions similar to what we are discussing, you guys shall not be able to miss. So in upper 11, we are told that a chord WX and YZ intersect externally at Q. As you can see on the diagram, the secant, you know, a secant is a line that cuts through a circle. A secant is a line that cuts through a circle. It's not like a tangent which just touches. When you look at SQ, that's a tangent. It just touches the circle. But if it crosses the circle, it becomes a secant. So a secant WQ is equal to 11 centimeters. Then QX equals to 6, while ZQ, as you can see, equals to 4. calculate the length of the chord YZ. Can we let this YZ be X? Just a small letter X, so that we don't confuse it with the existing X there. When chords are intersecting externally, this is how they relate. We have two chords here, WQ and YQ. They are intersecting at Q. So we usually say, if it's WQ, the whole chord, multiplied by the outer portion, should be the same as Y to Q multiplied by Z to Q, the outer portion, like that. So that gives us the relation that we're going to apply for chords that are intersecting externally. Okay, WQ is known to be 11 according to the instructions, multiplied by 6, which is the outer portion here. This is 11, it has been provided. Then this is 6 centimeters according to the instructions. Now, this should be the same as when we take YQ. Now, do we know the length of YQ? Not really. It's a 4 here and X. So 4 plus X multiplied by the outer portion, which is now 4. At this point, we can now talk about 66 being equal to 16 plus 4x. And this becomes is it 50? Equals to 4x. So that the value of x now becomes, when you divide through, confirm whether it's 12.5 centimeters, ladies and gentlemen. Confirm whether it's 12.5. It's a very good question. It's a very good question. 12.5. Very good question. Then now the examiner proceeds to tell us this. Using the answer in A above, find the length of the tangent SQ to 2 decimal places. Find the length of SQ to 2 decimal places. When you look at SQ, it's now a tangent. We usually say this. When we take the whole length, Y to Q, the whole length, Y to Q, multiplied by the outer portion, ZQ, we get the tangent squared, SQ. Get SQ squared. Can we substitute this? What is YQ? You know, for YQ, ladies and gentlemen, we need to talk about the X that you found, 12.5, and we add the 4, which is already existing, so 16.5. So we're talking about 16 multiplied by the outer portion, which is 4. This is equal to the unknown SQ squared. So to remain with Q now, QS or SQ, we now have to take square root of both sides. Square root of 66. Now this becomes 8.12. 8.12. And remember, we are also supposed to stick to the 2dp according to the examiner's instructions. 2dp like that. So that's it. That is the length of the tangent. Can we check number 12? Yeah, let's check number 12, ladies and gentlemen. Thank you for tuning. Thank you for remaining around for all those hours. Thank you for your patience. Thank you for supporting our programs. And here comes a powerful one for the December-November holidays, inviting all the students in secondary schools and also in junior schools. Kindly join us for a powerful interaction. Hoping to see you online. Reach out through the number attached, 0704 15 33 66. Look at 12. Find the possible values of x given that x minus 1, x plus 1, 3x, x is a singular matrix. One thing that you're supposed to be very conversant with is, do you know what a singular matrix is? If you know, you will agree with me that this is a matrix without inverse. Now, a matrix without inverse has a determinant which is equal to 0. So the determinant of this matrix now should be equal to 0. Therefore, how do we get determinant first? Product of the elements in the leading diagonal minus product of elements in the other diagonal. So we start with leading diagonal, whereby there is x and x minus 1 minus 3x multiplied by x plus 1. This now should be equal to 0. Determinant is given by product of elements in the main diagonal minus product of elements in the other diagonal. Let's talk about x squared minus x minus 3x now squared minus 3x equivalent to 0. We can now talk about the grouping of terms, ladies and gentlemen. When we group terms here, we shall have negative 2, the value of x squared. Yeah, because of x squared minus 3, it becomes negative 2. Then can we talk about negative x and negative 3x, making it a negative 4x equals to 0. Let me rearrange this. Instead of factoring now, I can rearrange to start with the 2x squared positive 4x. Then now, this is equal to 0. We can factor what is common. For example, 2x is common. This leaves us with only x and a positive 2. And this is equal to 0. At this point, can we talk about x equals to 0? When we take 2x equals to 0, x becomes 0. Or the value of x is also equal to negative 2. Because when we say x plus 2 equals to 0, then the value of x is confirmed to be equal to negative 2. So those are the two possible values. And you see the examiner is even guiding you, talking about two possible values of x, not just the value of x. Actually, when you see the value of x, that's a trap. That's a trap. The examiner wants you to know whether you are aware that when a quadratic equation is solved, we expect two values of x. We can check 13. Let's check 13. 13 looks like an interesting question from statistics too. Now determine the semi-interquartile range for the following set of numbers: 4, 9, 5, 4, 7, 6, 2, 1, 6, 7, 8. Interquartile range. You know, interquartile range is also called quartile deviation. We're also finding the quartile deviation. It's good for you to know these statistical measures. The first thing for you to find quartile deviation, or rather semi-interquartile range, you're supposed to, one, arrange the numbers in what you call ascending order. So to arrange in ascending order, we can begin with 1. Do we have 2? Yes. And how many 2's? This is 1, this is 2. After 2, do we have 3? Not really. We have 4, but 4 occurs twice. Then we go to 5. Then we go to 6, and 6 occurs twice. Then we go to 7, and I can see 2 7's. This 7 and this 1. Then we have 8, and we have a 9. So those are the set of number. That's the set of number in ascending order. So how many numbers are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have arranged all of them in what we are calling ascending order. Now, once that one is done, for you to get semi-interquartile range, you're supposed to get quartile range first. You're supposed to get interquartile range first. So to get interquartile range, identify the median first. How shall we get median for such a data? The middle value. You cancel 1, 9. You cancel 2, you cancel 8. You cancel 4, you cancel 7. You cancel 4 again, you cancel 7. Cancel 5, you cancel 6. And at the middle, we are having 6. So 6 is our median. Median is also called Q2 in statistics 2. Median is also Q2. Now, after that, you're supposed to know this, that median divides a set of data into 2 sets. The lower set of the data, the upper set of the data. With the lower set of the data, if we identify now its median in quotes now, we call it Q1, or rather the lower quartile. So let's identify lower quartile, Q1, and lower quartile is the median of the lower set of data after median has been obtained. So the lower set of data, 1, 5, 2, 4. We remain now with 4 here at the mid. So 4 becomes the lower quartile, which is Q1. Then, when we identify median for the upper set of the data, 6, 9, 7, 8, then we remain with 7 here. This now becomes our Q3, the upper quartile of the set of data. So at this point now, we are having Q3, upper quartile, and we are having Q1, the lower quartile. So now we can talk about what we call interquartile range. Interquartile range is the difference between Q3 and Q1. So Q3 and Q1, you know, this is a 4. Sorry, we had not listed them. And Q3 is a 7. So when we take 7 minus 4, which is 3, this is called interquartile range. Just the difference between upper quartile and the lower quartile. Then we can talk about something else that we call now the semi-interquartile range, which is given by interquartile range over 2, and this gives us 1.5. Yeah, that gives us 1.5. That gives us 1.5. A very good paper, a very good question. So you're supposed to know whenever you are given ungrouped data, those few statistical measures like semi-interquartile range, interquartile range, you know, something called a standard deviation, variance, something called mean absolute error, mean absolute deviation, sorry, should be found, all of them. When you visit our channel, ladies and gentlemen, you'll find that we have talked about all these statistical measures. And you're not supposed to wait for the exam blindly. No, you're supposed to be equipped. So kindly find your time. Find time kindly, and get to know what's happening in all the statistical measures. It's not healthy for you to stay waiting for, you know, a national exam and you don't know statistical measures, or you're there waiting for a national exam and you don't know commercial arithmetic too. We have done depreciation in this paper. Maybe in your case, it shall be appreciation. Maybe it shall be hire purchase, compound interest, taxation, all that. Please make shifting grades your friend. Visit our channel regularly and equip yourself with the right information. Now, a carrot patch is in the shape of a trapezium. There are 13 carrot plants in the first row, 15 in the second, 17 in the next, and so on. Okay. If there are 47 plants in the last row, how many rows are there and how many plants are in this particular carrot patch? One thing that you're supposed to know is that The carrot patch just begins like this. The reason why they are saying it is a trapezium, it's because they begin like this. You have 13 in a row. Okay, one row containing 13. Another row, they increase a little bit. They continue increasing until, until they are 47. So that's why they are occupying a trapezoidal shape like that. So now, this one, you are supposed to interpret it with reference to sequences and series and say, the first term here is the first number, which is 13 carrots. Then after that, the carrots are increasing. They move from 13 to 15. There is an increment of 2. Then from 15 to 17, meaning that there is an increment of 2 again, meaning that there is a common difference in this case, a common difference of 2. There is an increment of 2, a constant. Call it a common difference, the uniform constant which is added from one term until we get the next. Now, this behavior continues until we have a row, the last one containing 47. Meaning that if they are 47, then we can talk about the nth number now. The nth number is 47. We know that nth term in AP is given by A plus n minus 1 into D. And with this, we can talk about the 47. Which term is this? The first term is 13 plus n, which is unknown, minus 1 multiplied by a common difference that is known to be 2. Common difference to be known as 2. So with this now, even 13 can be subtracted from 47 very quickly. We get 34. After the 34 now, let's talk about opening of brackets. 2n minus 2. 2n minus 2. This is 34. So with this now, can we talk about 36? Because the 2 should be added, equals to 2n. Then n, which is the nth term now, should be 36 over 2, which is 18, of course. So we have 18 rows. So we have to determine the row which has 47 carrots in it. Then how many carrot plants are here generally? We talk about now sum. Sum can be given by several approaches. One, sum of n terms can be given by n over 2 into 2a plus n minus 1 into d, like that. Whereby, now we have found that it is 18 of them. So, if it's 18 of them, it's 18 out of 2. We want to find the total carrots. 2 by 13 plus n, which is 18, minus 1, multiplied by a common difference of 2. Yeah, we can apply the calc and come up with an answer now. Or we can simplify slowly. Okay, 9 into 26 plus 34 because of 17. Because of 17 times 2. Yeah. So 26 and 34 is already 60 times 9, which is 540 carrot plants. 540 carrot plants. After that stage, I was talking about a certain alternative whereby, finding the sum of n terms can also be given by n over 2 into the first term and the last term added. So 18, now that n was found, into 2, we talk about the first term, which is 13, and the last term, which is 47. Yeah, which is 47. See, this is 9 into 60, taking us to 540 still. So any of the two methods would have taken us to. the same number of plants, whereby we add from the first one to the last. When you are dealing with sequences and series, please know when to apply nth term and when to apply sum of a given number of terms. Number 15. Number 15 in the section 1, guys. Number 15. 2 brands of coffee cost 120 and 144 per kilogram, respectively. Now, a wholesaler blends the two and sells the blend at 168, thereby making a profit of 20%. Find the ratio in which the blends, or in which he mixed the blends. Can we talk about blends A and B, or X and Y, just any two unknowns? Okay, so let's talk about this. When this particular wholesaler mixed the blends, or mixed the brands to come up with the blend, we are having the selling price of 168, leading to a profit of 20%, meaning that 120% equals to 168, this particular selling price. What about the cost price of this after just blending? How much was the mixture costing? So we go to 100%, 168 by 100 over 120. This gives us what? 168 multiplied by 100 out of 120. This is exactly 140. So now, when the shopkeeper, or when the wholesaler mixed the two brands, the blend that was obtained was costing 140. That is why selling it at 168 led to 20% profit. So this is the first thing that you're supposed to get. A quick method, you need to say A and B, then we are having 120 and 144, costing 120 and 144. The two are mixed to give us 140. 140 is there. So we take absolute differences. 144 minus 140. This gives us 4. Then 120 minus 144. Absolute difference shall give us exactly 20. So now the ratio in which the first and the second were mixed, A is to B, shall be 4 is to 20. And of course, a ratio cannot be left unless it is in the simplest form. 1 is to 5. So that's how we work out such a question. Alternatively, on obtaining the ratios, we gave one a name. We have branded the brands. We have branded the brands. So we are saying that when we take 120 alternative times A, we are mixing A kilograms costing 120 and B kilograms, each costing 144. Then now we divide all this by the number of kilograms mixed so that we get the price per kilogram. We are mixing A and B. This should give us 1 kilogram, which is 140. Across multiplication will give us 120 A plus 144 B equals to 140 A plus 140 B. Then we can group some terms like 144. Just 144. 144 and 140. You subtract, you just get 4. The value of B equals to 140 minus 120, the value of A, we get 100 and we get 20. 20A. 20A, like that. So now can we remain with the value of A there? We divide through by 20. So 4 over 20, we're having a B here. 4 over 20, we can choose to take B to the other side, whereby you divide through by B. So simplifying this A over B should give us 1 over 5, implying that the ratio of A is to B equals to 1 is to 5. The first one is to the second. The ratio of the first one is to the second equals to 1 is to 5. We are finally in number 16. Is it in number 16 or at number 16? Or we are on number 16? Or we have arrived at 16, 0704, our consultation line, 153366. Okay, make X the subject of the formula. Make X the subject of the formula. We can see X has been incubated by a root sign. So we can square both sides of this. When you square both sides, ladies and gentlemen, P becomes power 4. It was already squared, so it becomes power 4. We are squaring both sides, so X now is here, plus 2W out of 4X plus 3R. Can we do a cross multiplication whereby P power 4 also multiplies 4X, and again, it multiplies 3R. X plus 2W. X plus 2W. That. Can we have all the terms that have X brought together on the same side of this particular equal sign? P power 4 and 4X minus X equals 2. We can have 2W minus 3 P power 4 R. Okay, so can we factor out X from this side? So that will remain with P power 4. Actually, it should be 4. We can start with the 4, yeah. 4P power 4. That way, minus, this is just 1, equals to 2W minus 3 P power 4 R. Can we remain with X, ladies and gentlemen? We divide through by the coefficient of X. Then now we divide all this by 4, P power 4 minus 1. This is now the earliest opportunity at which a student is supposed to get a mark for making X the subject of the formula. Later, we'll be focusing on the section 2 of this paper, but so far the paper 2, section 1 has been a very productive, very good session. If you've liked it, please share with a friend, subscribe to Shifting Grades, refer some friends kindly to our platform here, whereby we'll be offering very serious tutorials via Google Meet for junior school and also the senior schools. Our number is already attached, 070415 3366. Thank you for joining us. See you another time.